So far, I think it has been an amazing summit just to kind of see the different approaches to threat intelligence. Every time I think about threat intelligence, there are so many different parts in cybersecurity that kind of overlap, right? When you talk about like analyzing data, evidence, trying to make sense of all this information that gets captured from what a threat actor can do or has done, sent emails, etc. And as we think about all these different things that you need to do, even if you're a junior analyst, there's a lot of stuff that I believe generative AI or artificial intelligence actually can help. Not necessarily, I would say it will solve all your issues, but it could actually support a lot of these operations. So I hope that after this presentation, you can actually think about these things that you can do and take some inspiration from all the other speakers. Everybody has a way to do threat intelligence. So after this, I hope that you have all the tools that would help you build your own things and also get inspired and see if you can also become a cybersecurity AI enthusiast, for example. Oh, thank you. And once again, I'm Roberto. This is Thomas Rocha. We're cybersecurity researchers. And you can follow us actually in social media. And if you want to keep up with some of these experiments, all this research, you can just follow our blog post. And one big disclaimer, we are cybersecurity AI enthusiasts. We are passionate about the topic. We're not here to sell any products or talk about any products. We're actually here to share all the experiments, all the tools that we have built, and all the fundamentals and also practical applications of artificial intelligence, explicitly generative AI, to the threat intelligence field.
Thank you. Okay, so what will be covered in this presentation? So first of all, Roberto will walk through a short introduction about threat intelligence, about fundamentals of generative AI. But first, I will discuss more about the threat intelligence challenges. Then we will discuss also about some of the constraints of LLMs and some of the pitfalls that you may want to avoid. And then we will conclude this presentation by talking about some practical use case that you can apply to threat intelligence on your daily life. And finally, we will discuss about what could be the next step after this presentation for you. But first, let's discuss about some threat intelligence challenges we may have. So working in threat intelligence can be a bit difficult because it requires a big understanding of the threat landscape. Sometimes you are tracking threat actors for a long time, and it can take, it can be very time consuming to understand what are all the TTPs used by a specific threat actor. Also, there is a lot of information that are available. There is no day without a new threat report, without new data to process in your defense. And sometimes the data can be overwhelming. I call that infobesity. And also, new analyst curve is also very important because the new CTI analysts that are joining the field can take a lot of time to mature in the field and learn more about the techniques that we are using, but also the different skills and knowledge that we need for that. And last but not the least, the threats are constantly evolving, changing, and adapting to our defense. To continue on this presentation, Roberto will walk through some generative AI fundamentals.
Because that's super important. So either if you're doing defensive work or offensive work, understanding the fundamentals is super, super important. And we're going to actually go through some of these scenarios that will, hopefully after this part of the presentation, it makes more sense as we talk about some of the terminology also in artificial intelligence. So first, what's artificial intelligence? And this concept is thinking of a machine or a script that is capable to mimic some of this human intelligence and is capable to process information, process data in order to, let's say, generate a response like a classification. Maybe it can actually, generate some content for you. So it's just a way to have this semi-automatic capability with some human intelligence and just be able to learn also from all the data that it's exposed to. This is not new. Actually, artificial intelligence goes all the way back to the 1950s. Actually, 1956, artificial intelligence was used officially as a field. And when you start thinking about machine learning, it's a subset of artificial intelligence. It's a way to expose machines to data and then have them learn from data. Some of the techniques in here could be all the basics from, let's say, well, basics, statistical analysis to maybe using something like neural networks, which is a way to expose a machine to data and make it learn on its own, trying to figure out what are the most important features of the data so that then it can make a prediction, once again, or it can achieve a specific objective. Now, we have the concept of deep learning, which is a machine learning technique, where in this case, we are trying to extend the concept of, let's say, neural networks. And this is known as deep neural networks, which allows you to process larger amounts of data. So rather than just having a couple of pictures of cats, maybe, now you're talking about maybe the whole internet public information. So out of deep learning, we can actually get infrastructure, like deep neural networks infrastructures, that would allow us to process this massive amount of data once computation, storage, it's available. So in 2020, around that year, there is where all this technology, all this advancement actually make sense. And we were able to create, we in the world, not us, but the world was able to create these foundational models, which is a way to have all this amount of data available, make the model understand the language very well, and it's now capable to generate things for you. It could be text, it could be audio, it could be visual. So hopefully that kind of gives you an idea of like where generative AI actually is. And when we talk about foundational models, once again, it's a way just to expose this model to so much data that now it has some out-of-the-box capabilities that you can use. For example, if you have an email, you want to know if this is phishing or not, you can actually make a model that does understand language very well to derive some type of sentiment from the text, for example. So that capability could be out of the box because of the amount of data that it was able to learn from. And typically this would be, for example, a large language model is a type of foundational model. And the idea here is how can we train this deep neural network to predict the next word or the next sentence? So think about this. You have all this amount of data that now you could say, what if I hide certain parts of the text or the paragraphs, and I know what the output should be? I'm just going to train the LLM to understand or predict what that part is that I was able to hide in the process. By doing this process and making it learn on its own, now you have this like really good machine that truly understands text. And when you talk to them, to these chatbots that are using this underneath, you might feel like it's a conversation, but it's actually predicting some of the answers that you might want to infer based on your questions. And what actually captures the knowledge, it's the parameters that were used to tweak this model to actually learn from data. Now, this is a good table that I hope you can take, and you can start categorizing some of your work. When you talk about large language models, we're talking about natural language processing. So if you say, once again, if this email phishing or not, sentiment analysis is NLU, right? If you're talking about, let me get all this information that I want to process and summarize, that's natural language generation. Just a way to start being more organized when you talk about some of the ideas that you might have. Now, we all are familiar with this. We send a question, we expect a response, right? This is known as prompt-based interaction. Very simple. Let's just take it to the next level. When you send a question to these chatbots, you're not just sending text for the LLM to just process your text. There's actually two steps, at least some of the basic steps that are happening in the middle. One is tokenization, where you take the text, you can start breaking it down into small pieces, chunks, and this could be done by words, by subwords, and there's going to be an ID associated to these tokens. Next step is to take the tokens with the ID, get the vocabulary of embeddings of the LLM or the model, and pretty much what's happening here is saying this token that had ID 1, 5, or 7 has these numerical representations that the model is going to actually consume. So you're not sending text directly, you're actually sending numerical representation of the text or the question that you might have. And that's what is going to be processed. Understanding these basic concepts of tokenization and embedding, it's super important with a lot of the use cases that we're going to talk about in a little bit. Now, once again, it's not as simple as just saying, give me something. I want to know about this topic. I want you to do this. Like, there is actually some type of science art behind this. How can you shape the response of the LLM? Prompt engineering is a thing. And some things that you can do is you can define the role that you want the LLM to take. So you could say, I want you to answer my question this way, right? I want to actually not respond to questions that do have this context, right? You can actually define instructions. You can provide context. You can add some of that knowledge that you have, the LLM might not have, and then just extend or improve the response of the LLM. And finally, you can actually define the output. I want this in JSON, Markdown, Marmate, whatever, any format that you want. It's a way to shape, once again, the response to what you really want.
And something which is really important with prompt engineering is that it's more than just interacting with the chatbot. There is multiple techniques with that, such as few shot learning, retrieval augmented generation, and we will talk more a little bit later in this presentation.
Yes, very important, because once again, we want to take you to beyond to what everybody's used to at the moment, just interacting with a chatbot. We want to show you some of those techniques that you can use later. Now, there are challenges with LLMs. It's not all great, right? It's not that you're just going to access this chatbot and then have all your problems solved. Some of the challenges are, for example, timeliness, where let's say you ask for a MITRE ATT&CK technique that was released, in this case, in April 2023. And some models will tell you, I'm sorry, I can't answer that because that's from April 2023, and I only know up to 2021 April. I think that's the case of GPT 3.5. That's because when you're training these large language models, the data that you pass has a time window, right? If the training data was up to 2021, whatever happens after 2021, it will not know about. And some of the latest models out there, like GPT-4, will try to answer your question. And they will come up with this crazy definition of what that technique is, even though GPT-4 also does not have data up to October 2023, for example. So these are just some examples that it is not just as simple as exposing somebody to an LLM and say, whatever the LLM says, you should trust it. No, you should also have people that understand the topics that you're asking about so that you can validate those responses, right? Now, how do we kind of solve or improve this process? There is the concept of retrieval augmented generation. When I was learning about these topics, I heard RAG. I want you to RAG this and RAG that and RAG something else. And I was completely lost. RAG is pretty much how you expose an LLM to additional information that it doesn't know about, remember, because of the training data set. How can you ground the LLM, right? Just provide that context that might not be available. One, because it could be private information, right? So that's the basics of RAG. And a basic flow is like this. We take the knowledge, we tokenize it, we embed it. Now we all know what that is, right? And then we save all those embeddings, numerical representation of the data, into a vector database. Now we can use that when we ask a question. We could say, hey, I want to know about this threat actor, for example. There's going to be a retrieval process which could take your question, and it could apply one technique. There's multiple techniques, but one of them is the similarity search, where it takes your question, it's going to embed it. Now there is a numerical representation of your question. Then it tries to retrieve similar documents to the ones that are stored into the vector database. And now those relevant documents get pulled out of the database. And now you have your question with additional context that will shape your response a little bit better, right? That's how you expose some of this private data to an LLM.
And RAG is really an important concept because you can really train the model with your own data. So that's really important because if you are building models or capabilities in your own organization, then you have a way to teach a model with your specific data, and that's super powerful.
Yes. Now, so far, we have been thinking about this technology, let's say, LLMs, usually as a way to just Q&A. I want something, I want to know about this, I want to write a script, and you expect a response. That's great. That's actually good. But let's think about LLMs also as reasoning engines, as a way to be able to take your question, and since your question is in natural language, how you can make it actually think about your question and make it create a plan into what it is that, that it can do based on your question. That way of reasoning is super powerful for agents. And an agent in general is just a, let's say, for example, in this case, anything that can act on its own, make decisions. An AI agent is an agent that will mimic human intelligence and will be able to reason over your question. And then it's going to use tools to access the external world and be able to validate some of this reasoning. There is a concept of React. This is a basic framework that what it is that you can actually create this loop where when you ask a question, the LLM will think about it, will then generate what the action should be. The action is going to be executed. Observations are going to be taken out of the response of those actions. And if the LLM or the agent itself gets to the answer, then it will just respond. If it's not yet, and there is more things to do, it will just get into this loop, right? Thought, action, observation.
And keep in mind this loop because it's really important, an important concept for the rest of the presentation and for the next part,
yes.
Especially the action part, because an action can be anything in the context of an agent, such as a tool, as you said, and it can be also a RAG or different capabilities. But we will talk more a little bit later.
Super, super important. This is the concept that we wanted you after this presentation to take home, right? The agent, the LLM-based agents, which is, let's extend our initial prompt interaction. An LLM-based agent is how you use the LLM, once again, to be able to create a plan, reason, and then define the actions that you want to take. And if you're using APIs, for example, as tools, right? Let's say you expose or you want to access an API, those APIs will have input, right? Your parameters. So the LLM will be able to say, I believe that you need to execute these 5 things. I'm going to provide the input to those 5 things, and then let's execute it. The LLM does not execute things, so let's just keep that in mind. There's going to be tools that you will need to provide for that. And then the responses are going to be passed to the LLM. Sometimes it's to continue with a plan. Sometimes it's just to summarize the response and be able to send the data back. So once again, up to this point, we have explored all the fundamentals, and I hope that it makes more sense now when we talk about agents and how we're using our LLMs as part of this process.
Cool. Thank you, Roberto. So I hope you have a better understanding with the fundamentals. So let's talk about some practical use case that you can use in your daily work. Stick with us because I think it can change your way of working. It may sound a bit cheesy, I know, but I really believe on this technology, and I'm sure you can all, everyone here can bring to your home some takeaways. Okay. First example, so at the beginning of the presentation, we spoke about some threat intelligence challenges, such as, for example, the overwhelming data and a new day, a new report, a new threat report, new data to process, and so on. One interesting concept, and we just touched a few words before, is few-shot prompting. So few-shot prompting is basically a prompt engineering techniques that will teach through example an LLM. So in that case, this is an example where we are providing some previous example to the LLM, so it kind of learn what we are expecting as an output. So in this slide, what you can see on your right in the JSON file, you can see different information. So the first one is defining the role of the LLM. The role here is the system, and we are providing the guideline. The goal of this one is to basically have generating a mind map of the key findings from the threat reports. So here we define the guideline, and then we are providing some example, some few-shot example about the output that we are expecting. So first, the role, the first example, the role is the user, so this is you, and the content will be the threat report you want to summarize. And then you will provide an example with the role assistant, this is the LLM, and the content that you are expecting. And in that case, it's a mind map, mermaid flow chart. It's a code, it's an open code to generate mind map. And then we are providing example. So here, the content is truncated for the screenshot, but basically you can put, the more example you put in the few shot prompting, the better the result will be.
Yeah, and something very important here is that when Thomas talked about system user assistant, that's actually a chat template that some of these applications will have. So understanding how that template is structured, it would allow you to identify opportunities to provide those examples, right? And the providing the examples is actually known as in-context learning, how you provide that learning capability through your prompt, right?
So how does it work? So what is the output from this example? So this is the mind map. So basically, so in that case, it was a Cisco threat report where you just send the URL and the code will directly bring the report, summarize everything, and generate the mind map. So here you can see there is the key findings and different elements that could be interesting. And now you don't spend, let's say, 2 days reading all the threat reports. You have a way to summarizing everything in a single way, and then you can also share it with the rest of your team. The code is completely available. I published it on my blog, on my website, so you can reuse it by yourself. There is the link below, and you can experiment by yourself as well.
Yes. Sorry, go ahead.
No, go ahead.
Super important. I mean, super important use case, especially when you talk about exposing someone to so much data and be able to, you know, consolidate it, right, and provide a way to make it easier, right, for someone to understand.
Exactly.
Yeah.
So let's talk now a little bit more about RAG.
Yeah, so RAG, so how do we use this, right? We've been talking about RAG this, RAG that. But one example in threat intelligence is we all keep our own notes about threat actors. Some of you might actually have it into a database, for example. We know that a lot of that information is unstructured information, right? You can actually have, for example, IOCs, like about an investigation into a very structured database, but a lot of the notes, a lot of those long paragraphs that you're trying to explain what's going on, that's kind of hard to be able to create a framework to query all that information. So let's use RAG. One example is by taking the MITRE ATT&CK group's knowledge. That, to me, it mimics a little bit what not everybody, but I would say some of you might be doing already, which is creating a catalog of threat actors TTPs, okay? So we capture that, tokenize it, embedded database, and now we have that knowledge available for our LLM. And the way how this works, we do have, is already playing? No, okay, thank you. You can, and go. Let me click on it. There you go. Yeah. All right. So this first notebook, simple. It's just going to go through the process of using attack-CTI Python libraries that I created to be able to gather all this information from MITRE ATT&CK taxi servers. And then we simply create markdown files out of this, all this information from MITRE ATT&CK groups. So you get this list of markdown files, which you might have maybe OneNote, PowerPoint, Notepad, all this stuff, right? Then the next step is to index, put it into a vector database. Here we go through all the documents. We define the way how we're going to ingest all this and split the documents. We're going to tokenize all of that. And then we're going to then take all this information and then put it into a database. Some techniques in here is how can you overlap every single chunk so that you can actually maintain that relationship between all these different chunks. And then we simply put into a database, and now we can do a basic similarity search, or we can just initialize a retriever to expose some capabilities for searching. I did all this splitting of documents, and I contributed to Hugging Face. You should be familiarized soon about Hugging Face. It's like your GitHub for data scientists. And I published this data set so that you don't have to do the splitting, the chunking. And then you can download this and then use it embedded and then be able to use it in your POCs, for example. It's my first contribution. We are releasing a project called Intel Ragu. Ragu in Spanish, I think right away I think about tomato sauce. So just your sauce for Intel. And you can build a container. You can run the container. You can provide your OpenAI keys to be able to enable the chat kind of interaction. And then as you can see here, I'm just pointing to my contribution to Hugging Face. So all the data is being retrieved when the container starts. And now you have this kind of like chat version of this, chat version that you can actually talk to this data. So one question could be, what threat actors have interacted via messages with their victims? And if I query this, it will say, sorry, but I can't answer that right now because I don't have the context. And that's actually true because prompt engineering, I want to be more specific. What about messages that were exchanged via social media? And now it actually can get to the answer and says, oh, Fox Kitten actually did that. And all of this knowledge was unstructured data. So that's the power of RAG by having your data as a numerical representation and having a database that you can retrieve relevant documents, you will be able to interact and search this knowledge a little bit better.
Thanks. So remember earlier we talked about agent. And now I will show you like a practical use case with Mystic Pi. So for those who don't know what is Mystic Pi, this is a Python library which is open source and which is dedicated to threat intelligence investigation. So you can use it, you can use Mystic Pi basically for any kind of threat investigation. You can use it for example, to request some threat intelligence provider, enriching the data, creating some graph, do your investigation, and more stuff. So what I did here, I merged some of the capabilities of Mystic Pi with an agent. And what we do in this example is basically, remember, we talk about some tools, some tooling for the action part of the agent framework, the React, reason, action, and thought.
Action, observation.
Yeah, exactly. So basically here we are providing some tools to the agent. And here what I did, I created 3 different tools which are exported from Mystic Pi features. The first one is retrieve IP information, which is basically getting information about a specific IP that you are providing to the tool. And Mystic Pi will make a request to a threat intelligence provider. In that case, it will be VirusTotal. The second tool is retrieve communicating samples. So basically, you are retrieving any samples that are communicating to a specific domain name or specific IP, for example. And the third tool is retrieve sample information. So you are basically querying threat intelligence providers through, against a hash to get more details about what is this hash and so on. So if you have a look to the structure of tools, there is 3 different elements which are very important in the case of an LLM. The first one is name, because that's the name of your tool. The second one is the function that that the tool will call when the action will be decided. And then you can see the different tools on the left. And the last one is the description, which is actually a prompt. So this is very important because the LLM will base the reasoning and the choice of the tools based on this description. So this is basically a prompt where you define what the tools will be able to do. Very important to keep in mind. So let me show you an example. So it's a proof of concept, a small tool that we called Mystic Pi AI Assistant. And it's basically like a kind of a chatbot where you can directly interact with Mystic Pi to do some requests about some threat intelligence stuff. So,
and then you need to use yeah, click on it. There you,
perfect.
There you go.
So what we are doing here. So first, I cannot make pause. Okay. So first we are asking, can you give me more information about this specific IP? So what's going on here? The agent will go through the tools, request VirusTotal, and retrieve the information. And then we have information about the IP and so on. The second question that we ask is, how many samples are related to this specific IP? Again, the agent will reasoning, choose the right tools, and make the request to the threat intelligence provider to get the information. Something which is interesting here is I did not put the IP address again. So it keeps in memory what we just discussed. And here you have the 5 samples related to that specific IP. The last question I'm asking is, can you give me more information about the second sample? And again, I'm not even specifying the hash of the sample. He already knows which sample I'm talking about. And in that case, same thing, the agent get the questions. He think about, okay, I need to do something with that question. Which tool I have to choose? And then he decide to choose the third tool that we discussed, get sample information. And basically, he retrieve all the information from various total and summarizing all the output from the agent. And then the result, we have information about the sample. The sample is an executable. There is some signature related to the sample, and so on and so on. So we are basically automating the threat intelligence process about requesting some information about some specific IP, some specific domain, some specific samples, and so on. And rather than having multiple tools, we are centralizing everything in a single chatbot where you can directly interacting with it to get more information for your threat investigation.
One thing that I wanted to add in here is that you can actually think right now, wait a minute, but that's just a couple of scripts. I can build a process around it. I can build a couple of conditions, if, else statements, whiles, and then try to do the same thing. Yes and no. Yes, because yes, we're just trying to automate this process. But at the same time, what if you have, like Thomas was saying, hundreds of tools? You will have to build so many different conditions, and you will get to the point where there will be some edge cases that you won't be able to handle on the fly or adapt. That's the power of this, where the LLM is actually choosing what the tools it could use and building a plan based on your question. That's the true power. You can build some automations, but the moment you extend it, it starts getting very complex, which is the powerful of reasoning of LLMs on tools that it could use.
Absolutely. All right, before to conclude on this presentation, let's talk about some of the takeaway from this presentation. So first, Roberto walked through the fundamentals of generative AI to give you the knowledge and the basics about how generative AI is working today and what stuff we need to understand to be better with it. Then we're exploring some prompt engineering techniques, such as few shot learnings, retrieval augmented generation to train a model with your own data. And we finally discussed about agents, which are basically automating the whole process of threat investigation and where you can build your own tool directly with an agent and an LLM. The practical example that we discussed are very interesting. And this is some of the experimentation we did. And basically, the possibilities are endless. And it's up to you to explore by yourself with the key that we provided you today. But basically, there is a lot more to discover. For example, we discussed about one agent, but imagine a new framework with multiple agents that are conversing together, solving a specific task that you may have. Well, it's already existing. It's called conversational agent, and there is a framework which is open source as well, which is called AutoGen, that is doing that. So just to say that there is a lot more to discuss, and we hope that during this presentation, we provided you the key to explore by yourself and to learn more about this technology.
And something that is super important now is that when you leave this room, you're gonna have lunch, right? You'll have time to process all this. I want you to start thinking about what tools you can build. And so far, I'm actually thinking about it like maybe an open source project for a regulatory agent, for example. Sorry, my English is a little, so, you know, maybe an agent that understands all these regulations very well. You can talk to them and actually help junior analysts to really get up to speed. There is concepts like the top-down approach from log analysis from Bill. Let's build an agent around there, right? So there's a lot of different opportunities through the whole summit. I hope that you start thinking about that when you go back home too. And I hope that all these experiments and open source tools that we have released today help you, inspire you. And I can't wait to see all these open source projects.
Absolutely. And there is 3 resources at the end of this presentation, where it's two blogs where we discussed a little bit more about what we showed today. There is some codes that you can use by yourself, and more details about the concept we explained today. And lastly, the Intel Ragu is completely available today as well, so you can use it with your own data and try by yourself. Thank you very much.
Thank you.
If you have any question, let us know.
Appreciate it. Thank you.
I think, as they say, we're not in Kansas anymore, right? So guys, thank you. This was amazing. I think I speak for the most of us here and online that this was very, very much.
Thank you. That's awesome.
It's deep content. For me personally, I don't understand half of it, but you kind of helped me figure it out a bit.
Awesome.
There's a bit of a couple themes I'm seeing in the questions, both online and mostly posted in the chat, obviously. One of them, and obviously I do recommend to reach out to them individually, but a couple of them actually point out on some of the limitations on the things you presented. Could you talk a bit about that?
Of course. So what kind of limitation? Because there is some that we discussed during the presentation. And of course, like, for example, a model that you will use will be trained on a specific amount of data with a specific date. So of course, if you are, as we demonstrated during the presentation, if you ask some questions that are not part of the training of the model, it will be a bit more complicated to retrieve that information. So that's why we are talking about RAG, because you can extend the capabilities of a model with different data that are not already available in the model itself. Another limitation could be also, for example, trustly blind model, because we interact, today we interact with models with a chat. So it's like you are talking with someone, and some people are giving too much trust to this kind of output. So you need to be, what do you say? You need to have a critical mind to really understand what's the data, what kind of data are coming from the LLMs, and which data are wrong and which data are good. And so that's another limitation, for example, but it requires a bit of training, and you can also adjust that with prompt engineering, for example. Another limitation. Oh, yeah, go ahead.
No, I was saying like trying to put the right processes to be able to validate the
analytical processes.
Yeah. Well, yeah, yeah, exactly. So I think that's super important. And then some of the limitations that we see nowadays, let's say some of the limitations that happened actually a couple of years ago was about how much input, like how much text you can provide to the LLM. But the more we evolve, like the technology, the more it evolves, that token limit, now we know what tokens are, right? So the token limit, it's now extending so much that you can pass a lot of data. So some limitations today might not be limitations in the near future.
So also a bit the human factor. There's also some questions on how, for example, the output of what you query, how that can influence some analysts maybe to misinterpret results. Is there any thoughts forward to this? Obviously, when this field matures, we will see more applications. We know now how it works, but how do you see that field of analyst support evolving so that we make less mistakes or less wrong interpretations, for example?
Yeah, I think from the wrong interpretations and hallucinations, like that's like the word that, right, it's out there, like hallucinating about a topic. There should be companies or people that are building these apps to exposing them to a junior analyst, for example. There need to be processes to validate some of the adaptation of the LLM to that specific topic. If you're talking about regulations, I expect, for example, the PwC team, if they're building something similar, to have the experts in the matter to figure out what's actually a good response or not, and then improve that so the junior analysts are better, I would say, prepared to go through the data, and also knowing who to reach out in case something is not actually factual, right? Something
exactly.
Like
so AI auditing. Don't tell the big
auditing,
four,
exactly. Yeah.
Awesome.
Sure.
I'm gonna leave it. I'm gonna leave it here. Thank you so much.
Thank you so much.
This was well appreciated. Give it up for these guys.
All right, thank you. Thanks.